There are different methods for dissolution profile comparison, and this video is regarding those three methods mainly. First is F2 similarity, then Bootstrap F2, and third one is the MSD method for dissolution similarity. These methods are used to demonstrate that the dissolution is similar of the test formulation, you can say, along with the reference formulation or in comparison to the reference formulation. Also, these comparison techniques are used to demonstrate the product dissolution before change and after change, that is SUPAC. So if there are some SUPAC changes, if there are certain variations, you can say, into the formulation composition, API, manufacturing process, and some other things, then dissolution similarity is required to be demonstrated. So F2 similarity or F2 factor calculation, bootstrapping F2, and MSD methods are used. Before starting this video, I request you to go to this video, that is dissolution method development and profile comparison part 1 from these two videos, so that you will understand the terminologies better from this video. Dissolution profile comparisons are done mainly with the F2 similarity by calculating the F2 factor, then bootstrap F2 and MSD. There are certain limitations for the F2 factor calculation. There are certain limitations to the bootstrapping F2 also, and there are certain limitations for the MSD also. So bootstrap F2 and MSD methods are there after the F2 factor calculation or F2 similarity calculation. MSD is Mahalanobis or multivariate statistical distance. Dissolution similarity demonstration is an important and critical part of the QBD, and it is required for justification of the biowaivers. These techniques are used to compare test and reference drug profiles, and these techniques help for establishing the similarity for the regulatory acceptability of the dissolution profiles. F2 method is there, bootstrap F2 is there, and MSD is there. In F2 method, mean data is required. That means average profiles are used to demonstrate the F2 similarity or calculate the F2 value. Then variability is required to be limited. If variability is more or percent RSD or coefficient of variation is more, that time F2 has some limitations. An output of F2 similarity or F2 factor calculation is a single F2 value, which is required to be above 50, so that you can say that the dissolution profiles are similar. Then is the bootstrap F2. In bootstrap F2, the individual unit data is required and it can handle the variability. The output of the bootstrap F2 is confidence interval. Then coming to the MSD method, it requires individual unit data and it compares full profile plus variability. And output of MSD method, as it is a statistical test, it provides you the distance or simply a p-value. F2 similarity factor, it measures the closeness between the average profiles of the test and reference. That means two profiles are compared with the average. Acceptance is F2 should be above 50, and regulatory default acceptance is yes, it is accepted by FDA, EMA, and many other authorities. But it has a limitation that it is not valid with the profiles high variability or CV more than 20% for the initial time points and more than 10% at the latter time points. Then bootstrap F2, it is a non-parametric method using resampling. So whenever you are going to use the bootstrapping, at least select the 5000 value for resampling. It accounts for within batch variability and it provides the confidence interval for F2. Acceptance of Bootstrap F2, it is good for high variability profiles and some tools are required for this. Then multivariate statistical distance, it uses the individual unit profiles at all time points. It captures both within and between unit variability, outputs a statistical test that is a p value. It is powerful, but it requires some advanced tools and context specific regulatory acceptance is there. If the F2 similarity, Bootstrap F2 is not working for the resolution profiles, then you can go for the MSD. Bootstrapping F2 provides you some confidence intervals. F2 provides the F2 value and MSD provides some P values. So depending on to the requirement, you can use these type of techniques to show the dissolution similarity. So F2 method is used when dissolution shows low variability and it is used for simple generic comparisons. And Bootstrap F2 is used when the profile shows high variability and it requires more robust data and it is more robust submission type. MSD is used when complex products are there like modified release and some biologics. It is used for QBD studies, multi-point assessments. F2 is easy, but it has limited scope. Bootstrap F2 adds robustness and it is accepted by the regulatory authorities like FDA. MSD is the most powerful and it is best suited for the complex cases. So you can choose the methods depending on the product complexity, variability and the regulatory requirements. So this is regarding the resolution profile comparison by F2 similarity, Bootstrap F2 and MSD. Watch these both videos as I have mentioned earlier so that you will get the good idea about this topic. Thank you for watching the video.